Now we will review plotting polar coordinates and finding 3 additional representations of the points. If we want to plot 3 comma 4 pi over 3, we want to first find the angle 4 pi over 3, which is in the third quadrant. And then we want to go out 3 radii. So 1, 2, 3. So our coordinate would be located right there. So to find 3 other representations, we can use either different angles and different radii to represent the same point. So if we want to use a negative radius, we can say that if we follow along the angle pi over 3, but go backwards 3, we're on the same coordinate. So another point would be negative 3 comma pi over 3. We can also represent 4 pi over 3 as negative 2 pi over 3. So we can say that we went to the angle negative 2 pi over 3 and went forwards 3. We could also represent pi over 3 as negative 5 pi over 3. And we can say that we went to the angle negative 5 pi over 3, but went backwards. So we have negative 3, negative 5 pi over 3. Now we want to convert 3 comma 4 pi over 3 to a rectangular coordinate. So to do that, we need to know the 2 formulas. X equals r cosine theta and y equals r sine theta. So we just need to do 3 times the cosine of 4 pi over 3 and 3 times the sine of 4 pi over 3. So we already have the angle 4 pi over 3 drawn above, but we'll just kind of redraw it off to the side. And we know that 4 pi over 3 is a 60-degree angle. And our sides will be negative root 3, negative 1, and 2. So the cosine of 4 pi over 3 is negative 1/2. So we have negative 3/2 when we multiply it by 3. And the sine is negative root 3 over 2. So we'll have negative 3 root 3 over 2. In number 51, we'll review how to write some absolute value functions as piecewise functions. So for part A, what we first want to do is factor out the 3. So we have 3 times x minus 1, the absolute value of x minus 1 over x minus 1. So now, if we plug in numbers, we first of all can't plug in the number 1. So we can either plug in numbers that are bigger than 1 or numbers that are smaller than 1. If we keep plugging in numbers that are bigger than 1, like if we plugged in 2, we would get the absolute value of 1 divided by 1 times 3. So we would get a 3. And we would actually keep getting 3. If we plugged in numbers that were less than 1, say 0, we would get a positive on top and a negative on the bottom. So we would keep getting the number negative 3. To graph this, we want to go to the number 1 and go up to 3 and put an open circle, and go down to negative 3 and put an open circle. For all of the numbers bigger than 1, we're going to keep getting the value of 3, so we have a straight horizontal line. For all the numbers smaller than 1, we're going to keep getting negative 3, so we have a straight horizontal line. For B, if we want to write B as a piecewise function, we first have to figure out what our key point will be. So we set 5x minus 10 greater than or equal to 0. So we'll get x is greater than or equal to 2. So when x is greater than or equal to 2, we'll get our normal equation of 5x minus 10. Because if we plug in, let's say, a 2, we get 10 minus 10, which is 0. The absolute value is 0. If we plug in 3, we'll get 15 minus 10, which is 5, and the absolute value is 5, it's 5. So we keep getting itself. But when we start plugging in numbers less than 2, we're going to end up with the opposite. So we end up with negative 5x plus 10. For example, if I plugged in, let's say, the number 0, I would get a negative 10, and that negative 10 would turn into a positive 10 with the absolute value sign. The same thing would happen if I plugged it into negative 5x plus 10. Moving over to C, we have the absolute value of x squared minus 4x minus 12. So again, on the side, we want to set this quadratic greater than or equal to 0, and in order to solve it, we must factor it. So we get x minus 6 and x plus 2. So now remember, with quadratic inequalities, if it's greater, if we graph it on a number line, we have the number 6 and the number negative 2. Our arrows are going to go in opposite directions. For example, if I plugged in 7, we get 7 minus 6, which is 1, and 7 plus 2, which is 9. 1 times 9 is 9, which is greater than or equal to 0. The same thing would happen if I plugged in a negative 3. Negative 3 minus 6 is negative 9, and negative 3 plus 2 is negative 1. Negative 9 times negative 1 is a positive 9. So we get two answers. X is greater than or equal to 6, and x is less than or equal to negative 2. So the way that this translates into our piecewise function is that we get our equation x squared minus 4x minus 12 when x is less than or equal to negative 2, or x is greater than or equal to 6. Then it will equal the opposite when x is between negative 2 and 6. So when negative 2 is less than x, which is less than 6. For the next 4 problems, we're basically just practicing our algebra skills. So if we wanted to add 1 plus x over y, we would first have to get common denominators. So we would change 1 to y over y plus x over y. So our final answer would be y plus x, or x plus y over y. For number 2, we have b over a minus a over b divided by 1 over a minus 1 over b. So in this case, we want to multiply each term by the common denominator since this is a complex fraction. So since we are working with a's and b's, our common denominator will be ab. So we're going to multiply each term by ab and then cancel. So in the numerator, in the first term, the a's will cancel and we'll have b squared. In the second term, the b's will cancel and we'll have a squared. So we have b squared minus a squared. In the denominator, the a's will cancel, so we'll just have a b. And the b's will cancel, so we'll just have an a. We can further simplify this because b squared minus a squared is difference of squares. So we'll write it as b plus a, b minus a, all over b minus a, and our b minus a's will cancel, so we're just left with b plus a, or a plus b. For number 3, we want to expand and simplify. So first we need to expand x plus h cubed. So that will be x cubed plus 3x squared h plus 3x h squared plus h cubed. And then we'll take the negative 3 and distribute him. So we have negative 3x minus 3h And then we have negative x squared plus 3x. And this is still all over h. Now we want to see if we can simplify. So it looks like our 3x's will cancel. And that is it. So we have x cubed minus x squared plus 3x squared h plus 3xh squared plus h cubed, minus 3h plus h cubed all over h. And I think I made a mistake. I think the x squared is supposed to be an x cubed, so things work out a little bit more nicely. So let's change that to an x cubed, and we can cancel those. So now it looks like I can divide everybody by an h. So my final answer will be 3x squared plus 3xh minus 3 plus h squared. In number 4, we're working with another complex fraction. So I want to multiply by the common denominator, which would be x squared times x plus h squared. And also the numerator. Okay, so when we multiply by that, the x plus h squareds will cancel in the first term, and we're just left with x squared. The x squareds will cancel in the second term, and we want to leave the negative out in front. And nothing will cancel in the denominator, but that's okay because something might cancel later. So now we want to expand x plus h squared. So that will be x squared plus 2xh plus h squared and then we want to distribute the negative. So we have x squared minus x squared plus 2xh plus h squared and in this case our x squareds will cancel and we can divide the two terms in the numerator by the h in the denominator. So we're left with 2x plus h over x squared times x plus h. And that is the simplest that we can simplify it.